Alright, hello. So, I'm studying for calculus, and I decided, well, let's try some interesting study methods. And so I'm making a video tutorial on what I'm studying. And what I'm studying right now is related rates. I'm hoping they'll be on the midterm. I quite enjoy related rates. Some people don't like them. It's the closest thing I can get to physics right now, and I like physics a lot. So, yeah. So here we go. We have sides of a square increasing at a rate of 1 centimeter per minute. How fast is sides increasing when the sides are 10 centimeters long? So, when you're dealing with related rates, the first thing I want to do is draw a diagram. Diagrams are life. If you don't have a diagram, you don't have life. Okay? So, zoom, pre-drawn, yes. Look at that diagram. We have our square, because it is a square, and it's increasing at a rate of 1 centimeter per minute. So we have side x, and we're given that the change in x over the change in time is 1. So we know dx dt is equal to 1, which is change in x over change in time. 1. Simple as that. And yeah, so then we're going to need to find equation to relate the rates of change, related rates. Honestly. So like, let's say if we were going to say a triangle, you'd use Pythagorean's theorem. If like you were using a cone, you'd use the equation of area for a cone, whatever. Since we're using a square, there's only really two possibilities. We either have area, which is length times width, or length times width, which is x squared, or the perimeter formula. But we're not really using the perimeter formula here, so we can cross that off our list. What we're looking for is x squared, and we're going to want to state this as a function, well, just as a function. So we're going to say blah 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 blah. I'm just going to say f at x is equal to x squared. Simple as that. And now what we're going to do, it's hard to write and look through camera, so I'm just going to write over here. Since this is change, we're looking for the change in rate. So we're going to have to take the derivative of this. We're going to take the derivative. So we're going to say f prime of x is equal to 2x dx dt. Do not forget to write, oh, I was way over here. Do not forget to write dx dt. This is what solves your equation right here. This is what brings it together. Because as you can see, we have dx dt. We have it right there. Bam. Shazam. And we also have another given that I didn't really write down is we're trying to find when x is equal to 10. So we have dx dt is equal to 1 and x is equal to 10. Well, if we look down here, we have x and we have dx dt. So we can say 2 times x, which is 10, and then we have dx dt, which is 1, which is equal to, well, 2 times 10 times 1, 20. So f prime of x, or dx over dt, that's a really crooked t, is equal to 20. So we can see that the change in our x over the change in time when x is equal to 10 is 20. I know that's a really kind of a hard concept for some people to understand. But think about it this way. We're stating area as a function of time. And if we have our area here and we increase each side by 1, you're having essentially an exponential increase. You're increasing by more area every time you add 1. So when you add 1 here, you're going to increase by more area of this original than just adding here. I think that's a good way of explaining it. That's really how I think of it. Although most people just accept the fact that the answer is 20 and move on with their lives. So yeah, that is my first question on related rates. Let's see if I can find another one. See if I can find another little fun guy over here in my magical binder here. Let's I'm just gonna, you know what? I'm gonna put this in two parts. I'll be back.